Hello. In this lecture, we are talking about dimension reduction in machine learning. This presentation guides you through the process of dimension reduction, a vital technique in machine learning to simplify data and enhance model performance. We explore the concept of multicollinearity and demonstrating how to identify it using Python. Then we delve into principal component analysis and its implementation using Python to reduce dimensionality effectively. Uh, First, identifying multicollinearity in Python. Understanding multicollinearity. Multicollinearity occurs when two or more predictor variables in regression model are highly correlated, leading to unstable and unreliable model coefficient. This can hinder the interpretation of model result and affect prediction accuracy. Detection method. We can use various techniques to detect multicollinearity, include correlations, metrics, variance inflations factor, and against value. This method help quantify the extent of collinearity between predictor variable and guide us addressing the issue. Next is practical example detecting multipolarity. A correlation matrix. A correlation matrix visualizes the relationship between all pairs of predictor variable. High correlation close to 1 or 1 minus 1 and indicate potential multicollinearity. This can be generated using Python pandas library. Variance inflation factor (VIF) measures the inflation in the variance of the regression coefficient due to multicollinearity. If VIF value greater than 5 or 10 suggests strong multicollinearity requiring further investigation and potential remedial action. Next is principal components analysis (PCA). First, data transformation. Second, variance explained. Third, feature extraction. First, data transformation. PCA is the dimensionality reduction technique that transforms correlated variable into a set of uncorrelated linear combinations, known as principal components. These transformations reduce the number of variables while retaining as much information as possible. Second, variance explain. Each principal component explains a certain amount of variance in the original data. By selecting the components that account for the majority of the variance, we can achieve significant dimensionality reduction without sacrificing essential information. Third, feature extraction. PCA can also be used as a feature extraction technique, selecting the most informative components to feed into subsequent machine learning models. This can improve model performance and reduce computational complexity. Next is implementing PCA in Python. First, data preprocessing. Before applying PCA, it's essential to standardize and scale the data to ensure that all features have the same unit of measurement. This prevents features with a large scale from dominating the analysis. PCA transformation. Once the data is preprocessed, we can apply PCA using the PCA class from the scikit-learn library. This class allows us to specify the number of components to retain and perform the transformation. Third, component interpretation. After applying PCA, we can examine the components and their loading to understanding the relationship between the original variable and the newly created components. This can help us to interrupt the result and draw meaningful insight. Uh, Next is case study applying PCA to customer data. Variables. Imagine the scenario with 50 customer variables such as demographics, purchase history and website interactions, components. PCA identify 10 principal components capturing over 90% of the original data variance. Using the reduced dimensionality, a clustering algorithm identify two distinct customer segments with different preferences and behaviors.